Okay, so this is page 275. Multiplying a polynomial by monomial. What's a monomial? Just shout it out. Single term, right on, good. So we're going to multiply a single term by a couple terms. We will only do, like I said, why does it say late? I don't love algebra tiles, but they are fairly helpful. So I'm only going to do a couple of these ones. So remember, shaded is positive, white is negative. So let's look at B. So when we do this, it's saying this is an X tile times X, and then this represents 3. Did you guys do this at all last year in grade 9? Like set up like this? Yeah? Okay, cool. X times X is going to give us an X squared tile. And that's me shading it in. X times 1 gives me an X, and we do that 3 times. And then shade them in. So in total, I drew here an X squared tile and 3 X tiles. Back in grade 8, if I gave you a question like this, you would have been like, oh, that's distributive property with the little arrows. So then X times X gives us X squared, X times 3 is 3X. Do you remember doing things like that in grade 8? Maybe. Yeah, okay. Do you want to do another algebra tile one? Are we, yes, maybe? I heard some grunts, let's do one. Let's do D. There's positives and negatives here, so it's good for us to catch that to make sure we're remembering. Positives and negatives in this unit is going to be your biggest place of error, unfortunately. It just gets to be a lot to keep track of, and you're likely to make a mistake with positives and negatives. X times X gives us an X squared. So I'm going to draw a big square. X times an X gives us another X squared. Those were both shaded, so it's going to stay shaded. Then I have 1 times X, which gives me an X tile. The 1 was negative, so it's going to stay white as negative because that's a positive times a negative. 1 times X is going to happen again, and then 1 times X. So you're filling in the grid here, like you're filling in all the squares for what the shape is. So when I do it, it's kind of hard for me to show you without like being there. Let me highlight it. So it's like this guy times this guy. Then you're going to do that same 1 times this one. So you're going through them like that. So you're making sure every square is being multiplied by every square. That I would also just think you're going 2x times x, which gives us our 2x squared tiles, 2x times minus 2, which gives us minus 4x. Is that okay? Groovy. Okay, let's turn the page. So a question like this, they've given us our answer, and we're going to work backwards. So what are the 2 pieces we're multiplying together to get this product? With questions like this, there can be multiple answers because of positives and negatives. So on this first one, it has to be x long across the top. Let's say that's a positive x. Well, this side then right here has to be a positive x, because a positive times a positive gives us our positive x squared. So then vertically going down, this one also, by that same logic, has to be a positive, because a positive times a positive still gives us our positive x squared. What's going to go in this very bottom chunk then? A negative what? 1, right on. So this question is really saying x times 2x minus 1 equals 2x squared minus x. The diagram is saying what I've written there, our equation there. What is another way, though, that I could fill this in? Like, how is that going to change slightly? Jasmine. Good. Good, right on. Because a negative times a negative still gives us our positive. Negative times negative still gives us our positive. But in order for this bottom to be a negative x, we have to have a +1 little square. So this statement is now a negative x times negative 2x plus 1, which is still going to equal 2x squared positive minus x. Does that make sense? So it's just two ways to represent it. That's all. We've answered all the questions below right there for you. So we'll just leave those blank. So most often we're going to just use distributive property. You're in grade 10 now. These questions are going to be harder than those ones we've already done. So let's practice just distributive property with these a little bit more. I really like just using the arrows. I think the arrows are the easiest way to do it and to make sure you don't forget anything. So often we make mistakes in math, especially this unit, because we're rushing or being forgetful, not because you don't understand the content. So this first one, I'm going to go 2 times x, which gives us 2 x's. 2 times 1 gives us a 2. X times x gives us what? X squared. Good. X times 3 gives us 3x. 2x times x gives us 2x squared. 2x times 2 gives us 4x. Is that positive or negative? Negative. Good. This next one's a little bit trickier. I mean, not a lot, so but a little bit trickier. Negative 3 times x gives us negative 3x. A negative times a negative makes this a positive 3. Very small thing, easy to make a mistake on. This next one, they wrote it in a different order, but it's still the same idea. X times 2x gives us 2x squared. Minus 1 times 2x gives us a minus 2x. Referencing what we did yesterday, notice all of these answers, if we look at our degrees, the degrees are still going from the biggest degree to the smallest degree. That's our proper notation. And that's what I mean when I was talking yesterday. They kind of force you to do that, right? Like it just like naturally happened that the degrees lined up because that's how the questions we give you will go. Okay, I want you to try answering class example 3 on your own. I'll go over the answers, but try and do the distribution on your own and see if you can do it. Go ahead, share. Sherry. Good, right on. 7x plus 4. Good. Graydon, do you want to share B?
Okay, negative 10x squared plus 30 minus 5x plus 30.
Good, right on. That one was pretty tricky.
Oh, yeah. It's going to be 12. Yeah.
Yep, that's 12x. It's okay. Yep. My apologies. That's definitely 12x. Whoops. B is correct though. That's good. Priscilla, do you want to try C? C is tricky. We have exponent laws coming into C. Good. X to the power of 5 minus 2x squared. So remember, when you multiply powers that have the same base, we add those exponents. So 2 plus 3 gives us that x to the power of 5. The very last one, Ellie, do you want to try it? Okay. Nope, that's okay. Jasmine, do you want to try it? Good. So whenever you have multiple variables like these ones, generally speaking, we put them alphabetically. So instead of writing yx, we would write xy. Does it matter? No, because the order we multiply does not matter. But kind of like the math norm is to put them in alphabetical order. Raise your hand if you got all 4 correct. Nice. Nice. Good work, guys. Okay. We're going to try class example 4. So this is where it can be a little bit more difficult with when things are added in, there's multiple steps. I have to apologize in advance. Your workbook does not give you a lot of space. So have as neat of printing as possible. I think I mentioned this last class. This might be questions that's good to have like a pack of sticky notes with you, and then you can just add the sticky note in for extra space if you feel like you're going to run out of room, because taking out a separate piece of paper is then hard to look back on because everything's in your workbook, or just write really small. So a question like this, let's look at A. Can I go 6 minus 4? Is that my first step? No, good. You have to remember order of operations with this. I think it's best to think of this minus 4 as really like a negative 4. So include that negative with it. If you don't, it becomes really difficult and you're giving yourself more steps to do it. So let's rewrite the 6, and I'm going to go negative 4 times 8x, which gives me negative 32. Then negative 4 times the 1, which gives me minus 4. Am I done? No, good. What's left? Good, I can simplify further. The 6 and the 4 are like terms, so 6 minus 4 gives us 2. So 2 minus 32x, that's an okay answer. Better is to go negative 32x plus 2, because we want that highest degree to go first. The the negative 32x has a degree of 1 versus just a solo number has a degree of 0. That 2, there's not a sign in front of it, which implies it's positive. So that's why it's plus 2. Okay, this next one, we're going to do distributive property and then combine like terms. So in this one, 4 times 2x, so I get 8x minus 12. And then negative 2 times x, so minus 2x. And then negative 2 times negative 6, which gives me a plus 12. 8x and minus 2x simplifies to be 6x. And then my 12s just cancel out. So if it helps and it makes you feel better, you can say plus 0, or you can just say 6x. Nothing wrong if you want to put that 0 just to make you feel like I've covered my bases kind of things. C. So we have exponent laws in this question, we have distributive property in this question, and we have distributive property with just this subtraction symbol. It's really easy to forget that you have to multiply in that negative. I often like to think of it as like really it's like there's a negative 1 here, because then that might help prompt you to make sure you do that. So let's start at the beginning. 5x times 3x squared, I'm going to get 15x to the power of 3. 5x times 7x gives me a minus 35x squared. 5 times 1 just gives me plus 5x. Can I combine any of those? Like that I've written so far? No, good. So, and then this last part, I'm going to multiply in that negative, so then it's going to be minus 4x minus 3x squared. I only have one x cubed, so I'm still going to have 15x cubed. I have negative 35x squared, and then these negative 3x's. So that gives me negative 38x squared. 5 positive x's minus 4 x's leaves me with an x. If you wanted to say plus 1x, go for it. How is that? Do you guys see how easy this is going to be to make a mistake? This is the easy portion too. These are going to get like, you're going to feel really smart when you do some of these questions, because you're going to have like tons of x's and cubes, and it's going to be this big thing. And it just looks really intense. Okay, these next two questions like these are going to be like our level 5-6 questions. These are as like application style questions that we can get with this unit. as I identify which ones are like the appropriate levels throughout a unit, remember it's at that point in time. So like right now, this would be a level 5, 6, but in a week from now, it would probably only be like a level 4. Does that make sense? Because we're learning more. So the difficulty at this point in time right now is a 5, 6, but it does decrease as we do more and more. Does that make sense? Yeah? Okay, so we're going to find the area. We do lots of area when we're talking about multiplying, right? Because area would be like length times width. We're going to solve it 2 different ways. So the first way they want us to do is by adding the areas of 2 rectangles together. So I see 2 rectangles if I split it this way. Do you guys see 2 rectangles then? Cool. My first rectangle, oh, that's a bad rectangle. So our top rectangle is 3x plus 2 long by 2x tall. So if we calculate the area of that guy, I'm just going to multiply them. On a question like this, I'm showing a lot of work. I'm trying to make it as clear as possible. You could show the work kind of as you need to here. So we're going to multiply 2x by 3x plus 2. Say that again, Khalil. No, it's going to be this little chunk shorter. Okay, so when I'm doing the area of my top rectangle, I get 2x times 3x, which gives me 6x squared. 2x times 2 gives me plus 4x. So this area is equivalent to that. The second area is a little bit trickier, though. I know it's x plus 5 long. Do I know that measurement? Go ahead. Good. We know this whole length is equal to 4x, correct? I know that this chunk, though, is equal to 2x. Therefore, this has to be 2x, right? Because 2x plus 2x gives us those 4. So this is also 2x tall. So when I multiply this out, we're going to get 2x squared plus 10x. Am I done? No. What's left? Good. So my total area I'm going to write it out. Again, you could probably skip this step because you've shown so much work at this point. So we have 6x squared plus 4x plus 2x squared plus 10x. So I can combine my x squares together to give me 8x squared, and then my regular x's to give me 14x. That is, I showed a lot of work there. I really broke it up. I'm going to do the second one slightly different so you can see how you could condense showing your work a little bit more. So we're going to find the area of if it was like a completed big massive box, and then we're going to subtract this area of this little guy. Does that make sense? So we're going to take the big area and take away that little chunk, so we'll be left over with everything else. So when I write it out, this is a way to do it. So I would write T with a little a being our subscript, so that represents total area. You'll often see things written in math like that. So then I would do like the area of my big rectangle minus the area of the small. So my big rectangle is 4x tall by 3x plus 2 long, right? So that's these 2 dimensions. My little rectangle, we've already discussed, it's 2x here. What is this measurement, though? Go ahead, Jasmine. How did you figure that out? Good. So she took her long measurement of the top and subtracted off that little measurement. So she did 3x plus 2 minus x plus 5. So you have to distribute that negative through. And again, you guys, I'm writing out a lot of work. Something like this, you might be able to just do in your head, or like look at it and do it in your head and have to think it through. You do not have to show this much work. So 3x minus x leaves us with 2x's. Oh, this, yes, 2 minus the 5 gives me minus 3. Does that make sense how I did that? Potentially? Okay, so then that's that little length over here. Your check, if I add these two together, it should equal my top, right? If I add these two together, I should get 3x plus 2. 2x plus that x, I have my 3x's. Negative 3 plus 5 equals 2. So we know we've done that subtraction right. So that's our good check along the way. So let's finish solving this one. So when I'm going to multiply this first piece together, I get 12x squared plus 8x. I'm going to do this in a couple steps because we still have to find the area of our small square. So I'm just going to rewrite that negative sign. And I'm still going to put some brackets in here. 2x times 2x gives us 4x squared. 2x times minus 3 gives me minus 6x. Now I'm going to distribute that subtraction sign through. Could I have done that in one step? Totally. But I want to show you that you just don't necessarily have to. I'm going to combine my like terms, so 12x minus 4x, I still get 8x squared. Sorry, I should have been saying squares on those. And then 8x plus 6x is 14x. Did I get the same answer as the first time? Should I get the same answer as the first time? Yes. So if I was to give you this question, say on a test or an assignment, I would probably personally follow up with like a part B being like, now let's say x is equal to negative 2. What is the actual area of these squares? So then you would plug in negative 2 for x and actually solve. They just haven't done that, but doing that extra step is really helpful because then it gives you a little bit more meaning to it as well. How does that feel? Does that make sense? We're feeling okay? Cool. That's it. So these are the questions I want you to do on this one. First, finish any questions you didn't finish from lesson 1. We have quite a bit of time left, so we have about 45 minutes to be doing these questions. So finish yesterday's first, and then finish these. The only reason I say that is you're likely to forget about finishing yesterday's if you don't do it first. And these are the other questions. You are welcome to listen to music and do this with a partner if you have masks on and are safe. It does not need to be silent in here.